Okay. Uh, so let us quickly start now. So in the previous class, I think we have covered the design of cylindrical wall. Okay. So we will continue with the previous topic, and we'll start with the design of roof dome. So this ends, sorry, not ends, ground service reservoir (GSR) uh, can be having two types of roofing structure. One can be dome, and other can be your simple circular slab. Okay. So the slab, circular slab portion we will cover when we will go for the design of jackwell. So here in GSR now we are going for the design of dome. Okay, we can provide both. Okay, so let us quickly study the design of dome. And dome is basically a curved structure, and the basic purpose of this dome is to transfer the vertical load in form of a hoop tension as well as the longitudinal stresses. Okay, so now as far as the problem statement is concerned, the rise of the dome is given to you as the diameter of the tank divided by 10. This was already defined in the previous class problem statement. So if you go back, so you'll find the diameter of the wall. Okay. So I think we have taken the diameter of the wall, that is capital D, at 6.6 meters. Okay, so you can see over here the D is nothing but your 6.6 meters. So accordingly, now we have to find out the dimensions of the uh, dome. So this diameter is basically 6.6 meters. So if you go with d by 10, so your r, that is the rise of the dome, that comes out to be 0.66 meters. Okay, so this much portion. Okay, so I'm talking about this portion. So this portion is nothing but 0.66 meters. As far as this diameter is concerned, so this diameter is now 6.6 meters. Okay, so if the rise of the dome is not given in the problem, you can always assume the rise of the dome in the range of d by 8 to d by 10. ओके, इट्स अप टू यू. उसका राइज बहुत ज़्यादा भी नहीं होना चाहिए, बहुत कम भी नहीं होना चाहिए. ओके, so these are the standard things. Now accordingly, now we have to find out what will be the radius of the dome. Okay, so here this is nothing but the radius of the dome. Okay, so this is nothing but the radius of the dome. So radius of the dome can be calculated using this expression. Okay, so from here r, that is the small r is nothing but the rise. Okay, so the rise is nothing but 0.66 meters. Okay, this is 2 into capital R is the radius of the dome minus rise of the dome, that is 0.66 bracket complete, equals to, this will be d by 2. So d is nothing but 6.66 divided by 2 whole square, and if you solve this, you will be getting the capital R, that is the radius of the dome. Okay, so please do the calculation and tell me the value of R. Everybody, please do the calculations. Sorry, 8.58. Somebody please verify, cross check. 8.58. Okay, so your R is nothing but 8.58 meters. So this R now will be 8.58 meters. Okay, now accordingly, now you have to find out the angle of theta also. Okay, you have already calculated the small r is nothing but the rise. So rise is nothing but 0.66 meters. Okay, so now you have to calculate the value of theta. Okay,
Sir,
yes.
Sir, your screen is not visible.
It's visible.
My screen is not visible.
No, sir.
Yes, sir.
Okay, let me share one more time. Okay.
Sure, sir.
Yes, is it visible now?
Yes, sir.
Okay. Let me change the mode to PowerPoint mode. Okay. Now is it visible?
Yes, sir, visible.
Yes, sir.
जस्ट हाँ अभी बताओ अभी विजिबल है
हाँ, sir.
ठीक है फुल स्क्रीन दिख रहा है
हाँ, sir. हाँ.
ओके फाइन फाइन so I have already calculated the radius of the dome. Now I have to calculate the angle theta. Okay, so I think this theta, this is also theta. This is not phi. This is theta. Okay, so now can you calculate the value of theta? Because you see, we have a simple triangle which is like this. Okay, so this is nothing but d by 2, that is half of the diameter. Okay, and this much length is nothing but radius minus small r, that is the rise of the dome. Okay, so from this now can you calculate the value of theta? कितना आ रहा है? Yes, anybody? बोलो जल्दी बोलो. 22.61. Everybody? Okay, so this theta, this is 22.61 degrees. Okay, so this value of theta will be required in the further calculations. Okay, so right now we have decided the dimensions of the dome. Okay, so it has got rise 0.66 meters, the radius will be 8.58, and the theta angle will be 22. Okay, now as far as this loading is concerned, so we have different types of loadings on the dome. So first thing is the dead load. So for the dead load purpose, we need to first of all, just to start with, I am assuming the thickness of the dome as 100 mm. 100 mm is nothing but 4-inch thick. Okay. So usual in slab also you start with 100 or 125. Okay. So depending on your experience, you have to just assume certain value. So I am assuming this as 100 mm, and later on if I find that this is not sufficient, then we have to increase the thickness. Okay. So if I take the assumption, if I start my design with, let us say, 100 mm thick dome, in that case the dead load of the structure will be the thickness multiplied by the density of the concrete. Okay. So here the thickness I am assuming this as 0.1 meter, and density of concrete is now 25. So if you solve this, so the dead load which is coming, it will be nothing but 2.5 kilonewtons per meter square. ठीक है, a very simple calculation. Then live load. So see, this is a underground water tank, so there is a possibility that some live load will be there on the tank dome. Okay, so based on the IS code we have to take the minimum value. So generally in residential building and all, we have seen the live load is taken as 1.5. Okay, so I'm barely assuming the minimum live load on the dome as 1.5. So the total UDL, or the total pressure which will be coming on the dome, will be summation of 2.5 plus 1.5. So the total load here, this will be now 4 kilonewtons per meter square. Okay, so now here you see, over this load, okay, so on this dome there will be 4 kilonewton per meter square. This load will be acting, and now because of this vertical load, two types of stresses are developed. Okay, So one which is shown in red color, it is nothing but your meridional stresses. So meridional stresses is basically caused due to the meridional force. So along the meridian of the dome, what will happen? The load will be transferred. Okay, so it will be giving a compressive force in the concrete. Okay, so you can see from the arrows of the red arrows. Okay, so direction of the red arrows, so you can see the concrete is getting under compression. Apart from that, there will be hoop stresses. Okay, so hoop stresses will be developed because the dome will be able to, or the due to the application of the dome will be expanding. Okay, so because of there is a expansion, so there will be increase in the diameter, and because of that there will be a hoop tension. So now we have to take care of both these stresses. One is the meridional stresses and second one is the hoop stresses. Okay, so let us see one by one. So just to show in animation, you can see I'm talking about the meridional stresses, that is along the circumference, not along the circumference, along the meridional. So here if you see, it looks like this. Okay, so along the meridional, the stresses are developed like this. Okay, so now for this purpose, first of all we need to calculate what are the forces along the meridian. Okay, so for this meridional thrust has to be calculated, and meridional thrust can be written as a letter T. Okay, so along this direction there will be a force, it will be like this. Okay, and here also it will be going like this. Okay, so this thrust can be calculated, and using this expression mt as w into r divided by 1 plus cos of theta. Okay, so we already know the w, so w value is nothing but 4. The r value, that is the radius of the dome, it is nothing but कितना आया था 8.58, isn't it? So this will be something like 8.58 divided by 1 plus cos of theta, where the value of theta is 22.61. Okay, so this thrust will be maximum over here. Okay, so if you calculate the thrust over here, it will be lesser. If you calculate the thrust over here, it will be even lesser. So as you move towards the end of the dome, this thrust is going to get increased. So we have to find out what is the maximum thrust. So for this purpose, we are taking whatever the value of theta is there. This is the maximum value of theta, that is 22.61. So we have taken this value. So now can someone tell me what will be the value of maximum or the meridional thrust? Sorry? 17.85. Everybody? Okay, so let me note it down. So this is 17.85. This will be in kilonewtons. Okay, I am saying per meter because it is per meter along the circumference. Okay, so this is 17.85. Now this thrust is going to crush the concrete, and it will be under direct compression. Okay, so for this purpose, let us calculate the meridional thrust, meridional stress. So we have already calculated the thrust. So thrust is 17.85. Now I am going for 10 to the power 3 because I want everything in Newton per mm square. Whereas the cross section area, what we have assumed is the thickness as 100 mm, and per meter, so it will be 1000 mm. Okay, so how much will be this one? So this 1000 and 10 to the power 3 will be down. I think this should be something like 0.1785. Okay, this will be newtons per mm square. So this value should be less than the permissible stress in concrete under direct compression. Okay, so as per the IS 3370 part 2, so the value of M25 grade concrete is 8.5 newtons per millimeter square. Okay, so definitely now you can see the stress which is coming due to the meridional thrust is very small as compared to the permissible stresses. Okay, I hope this is clear to everybody. Okay, so let us, shall I proceed further? Okay, now the second part is the circumferential stress. Okay, we also call it as a hoop stress. So like I said earlier, because of the vertical loading, the dome will be subjected to expansion. Okay, so this expansion will look like this. So you can see this is the front view, and you can see this is the isometric view. So you can see the tension is developed more along the circumference. Okay, that is at the edges. Okay, so let me play it one more time for you. This one. So you can see the more tension is there along the edges where the dome is getting supported. So if you refer this particular figure, some portion, okay, that is if you see this much portion, so this portion will be subjected to compression, but from here to here this will be subjected to tension. We don't have to worry about compression because it is made up of concrete, and concrete is very good in compression. All we have to do is we have to take care of the tension part. Okay, so now you just now we have seen in the figure, in the animation, that the maximum tension will be there where the dome is ending. So where the angle of theta is there, the theta angle is nothing but your kitna apna 22.61. So at that particular angle you will be getting the maximum stresses. Okay, so first of all let us calculate the circumferential force. So circumferential force can be calculated, the equation is there in front of you. So here the value of w is already 4. Okay, this is I think 8.58. R value is 8.58 and the theta value is 22.61. So this is 22 and this is also 22.61. Okay, so can someone tell me how much will be the circumferential force along the circumference? Sorry, 13.8. Somebody please cross check. 13 point कितना आ रहा है? 13.8. Okay, so this is 13.8. This will be kilonewton per running meter. Okay, that will be along this direction. Okay, so now if this is the force, in that case we have to calculate the stresses. So stresses is nothing but force divided by area. So here this will be 13.8 into 10 to the power 3, whereas your cross section area, your thickness is 100 mm multiplied by 1000. So I think this is coming out to be कितना आ रहा है? 0.138 newtons per millimeter square. This should be less than the permissible stress in, because here the concrete is subjected to tension, isn't it? So the permissible value for M25 grade concrete as per IS 3370 part 2 is 1.3 newtons per millimeter square. So therefore you can see the value is in the well within the permissible limit. So we can say yes, this dome is safe. Okay, so we don't have to worry about the cracks and all. Okay, so it's a very simple design. Now as far as reinforcements are concerned, so for the reinforcement as such there is no bending happening. Okay, only there is a hook tension. Okay, and there is a meridional thrust. So everything is within the permissible limit. So what we have to do is we have to provide a nominal reinforcement. Okay, so nominal reinforcement as per 3370 part 2, we have to provide the minimum or the nominal reinforcement that is 0.24% of the cross section area. Okay, this is the minimum reinforcement required as per the IS code provisions. So the 0.24% is 0.24 divided by 100 multiplied by the cross section area is 100 mm multiplied by 1000 mm. So this gets cancelled, and as a result of this you will be getting the AST minimum as 240 millimeter square. Okay, so now just tell me what will be the spacing if I use 8 mm dia bars. Somebody? Sorry, 209. So shall we provide this much spacing? Why? हाँ या ना? नहीं तो कितना प्रोवाइड करना चाहिए? नहीं तो कितना प्रोवाइड करना चाहिए? बोलो. See, we have to provide the spacing as per the code of provision, but the spacing is coming out to be very very large. So usually what we do, whatever is the thickness of the section, we generally do not provide more than the thickness of the section. So here in this case, in place of providing 8 dia bars at 209, 209 ko if you round it off on the lower side, it will come out to be 200, but still your 200 is very large. So what will happen if you provide a reinforcement of 200 by 200, there is a possibility of punching. So for this purpose, what we do is we cannot provide a spacing of bar which is greater than the thickness of the section. So in place of providing this, so what we have to do, we can provide 8 dia bars at 100 center to center, and this we have to provide in vertical direction as well as in the horizontal direction as shown in the figure. Okay, so please draw a appropriate figure. Okay, and then we can provide this much of bars. Okay, that's why I have not chosen 10 dia bars, because if you go for 10 dia bars, the spacing will be even more, but anyway we have to provide at 100 center to center only. And at this point there is no point in increasing the thickness, because your stresses are already very very less than the permissible limits. Okay, online students, are there any queries?
No, sir.
No, sir.
Okay. Yes, shall I continue? ठीक है. So let us go to the new topic. This is the design of top ring beam, right? So what happens is whenever there is a meridional thrust which is coming, and if it is coming directly on the wall, which we have designed in the previous class, then what will happen? The structure is going to behave like this. Okay, so it will tend to expand. So just to reduce the expansion, what we are doing is we are providing a ring beam just to support the meridional thrust which is coming due to the external loading. Okay, so this beam is basically a tension beam. Okay, basically it is a tension beam and it is designed to resist the tension. Okay, now for this purpose we need to know how much tension is there in that particular beam. So for this purpose, we have already calculated the meridional thrust. Okay, so let me go back. So meridional thrust was coming out to be 17.85. Okay, so here I have this value as 17.85 kilonewtons. This was coming like this. Okay, now if I take the value of theta, I think the theta value was 22.61. So this is 22.61 degrees. So all we have to do is take the cos component of this, so that you can get the circumferential force which is coming like this. Okay, so your circumferential force, now this can be calculated as simply 17.85 into cos of 22.61. Okay, so please tell me the value. बताओ, जल्दी बताओ. Sorry, 16.48. This is in kilonewtons. Somebody please cross check. Okay. So now this is the force which is coming like this, and since this is circular in nature, so we have to calculate the corresponding hook tension. Okay. So hook tension, we have a simple basic equation. This is the circumferential force. So circumferential force is 16.48. Your diameter, I think it is diameter kitna tha beta? I think it is 6.6. Okay. So this is 6.6 divided by 2. Okay. So how much is the hook tension? बोलो 54.38 correct है? Okay, so this is 54.38. This much is the hook tension. Okay, so now we all know that concrete is weak in tension. So हम लोग concrete के भरोसे नहीं रह सकते. So we have to provide the reinforcing bars to resist this much of tension. Okay, so for this purpose, what we are going to do is we are going to calculate the AST for the hook tension of 54.38. I am going for 10 to the power 3 divided by what will be the sigma ST value? 130. Okay, because for Fe415 grade steel, whether it is bending tension or axial tension, the sigma ST value as per IS 3370 has to be taken as 130. Okay, so how much is the this? Sorry, 41 mm square. Okay, so this is the amount of steel which is required in the beam so that it can resist the maximum hook tension. Okay, so now we have to calculate number of bars. Here by mistake I have written calculate spacing. It should be number of bars. Okay, so what will happen if I take 10 mm dia bars? How many numbers are required? If I take 10 mm dia bars, how many number of bars are required to cater 418 steel? 6 कितना आ रहा है 5.32. So we can go for 6 numbers. Everybody is getting 6. ठीक है? आ रहा है? ठीक है? So we know that now we have to provide 6 number of bars to resist the tension. Okay, now we have not yet decided the beam dimensions. Okay, so beam dimensions, they are basically depending on the size of the wall as well as the size of the dome. Okay, so size of the dome, if you remember, this was 100 mm. ठीक है, ये कितना था, वॉल कितना था अपना, वॉल कितना था? I think it was something like 150 tha. I am not sure. Yeah, 150 we have taken, right? So now you have to choose the dimensions of the beam greater than this. So this was 150 mm. Okay, so what we can do is we can provide the beam which is having 200 by 200, because this is just a concrete beam. Okay, but the tension part is taken care by the steel only. Okay, so now we can assume the dimensions over here as, let us say, 200 by 200. Okay, so the sum portion of the tension will be taken care by the concrete and remaining will be taken care by the steel. So for this purpose we have to check for the stresses also. Okay, so we already know the hook tension maximum value. So this maximum hook tension was coming out to be 54.38 into 10 to the power 3. So the area of the concrete is nothing but 200 by 200. AST is nothing but your 6 into pi by 4 into 10 square. बराबर है? M value, I think we have calculated M value previously. What was the M value? I don't recall. Let me check. M is 10.98. Pakka? Yeah, 10.98. So, yeah. So this is 98. Okay. So now can someone tell me how much will be the stress, tensile stress? So this will be a combined effect, that is concrete as well as steel. 1.34. ठीक है. So you are getting this as 1.34 newtons per mm square. So now what should be done? क्या कर सकते हैं? This is not less than. कितना आ रहा है? Area of the concrete you are taking 200 by 200. 1 point. Please check. 1.2 आ रहा है. पक्का? Okay, anyway, so if this is 1.2, okay, fine, it is safe. If it is greater than 1.3, 1.3 is the permissible value or the permissible stress in concrete in direct tension for M25 grade concrete. If it is greater than 1.3, in that case you have two options. One, you keep the reinforcement same but increase the size of the beam, or else you can increase the diameter, or you can increase the number of bars, or basically you can increase the reinforcement, or you can do even both. Okay, there is a very little margin if it is 1.34. Okay, so you can either go for say in place of 6 bars of 10 mm dia, you can go for 8 bars of 10 mm dia. Okay, that way is okay. Otherwise, in place of going for 200 by 200, you can even go for 250 by 250 size of the concrete. Okay, that way also it is acceptable. Okay, both ways are there. Please note down the reinforcement details correctly which I have shown over here. नहीं दिख रहा है? ओके, मैं वैसे भी शेयर कर दूंगा तब ये कर लेना. सो बेसिकली ऑन द टॉप डोम this particular sketch shows the reinforcement on both the sides. Okay, we have calculated the reinforcement only on the one side. Okay, so you can provide the reinforcement on the both sides also. Vertical bar reinforcement is already there. The shear link which is there in red color, that is showing nothing but your main reinforcement. You can see there are six bars. Okay, so 6 bars can be easily seen over here, and there is a nominal shear reinforcement. So as per IS 456, whatever nominal shear reinforcement is required, okay, that reinforcement you have to provide in form of a stirrups. Okay, and it is required not to resist the shear, it is required just to keep the bars in the position. Of course they will be contributing towards the shear also, but as such on this beam there won't be any shear because this will be subjected to axial tension only. Okay, so accordingly you have to go for the design of shear force, shear reinforcement. Okay, so shall I continue? Fine. Now coming to the base slab. So usually what we do is whatever thickness of the wall is there, so we have to assume the base slab thickness which is greater than the thickness of the wall. Okay, so right now I think we have taken the thickness of the wall as kitna 150 tha apna, है ना? So we are assuming that 150 plus 100 mm. So if you consider the thickness of wall as 150, so this comes out to be 250 millimeters. Okay, so this is just assumption. So if it is required, we can even revise the thickness of the wall. So generally what happens is we are providing this projection. Okay, So this side we have a central portion. This is your wall. So this projection generally it is having 3 to 4 inches. Okay, if certain in some certain circumstances this may be even increased also, just to prevent the uplifting. Okay, anyway, so we are taking a very nominal value of 3 inches, that is 75 projection for this particular portion. Okay, now as far as the design is concerned, as such, what will happen whenever the tank is full? What is going to happen? There will be a water pressure from the top. At the same time, there will be a ground reaction. So as such, the slab is not going to subject it to bending. Okay, bending will not be there. When bending will come into picture? When the tank is empty. Okay, and since the tank is empty, the self weight will be acting on the slab itself. In that case, there will be a possibility of hogging movement. This is the only possibility where the slab will be subjected to bending moment. Okay, and the tank weight is not that much. It is very small. So for this purpose, what we generally do is we provide the bare minimum reinforcement, and this bare minimum reinforcement has to be provided at the top, not at the bottom. Why? Because in case of bending, the bending will occur like this. Hogging bending moment will be there, not the sagging one. Okay, so for this purpose, we have to provide the bare minimum reinforcement at the top. Okay, so this is again, this is to 0.24% of the cross section area. So that is 0.24 divided by 100 multiplied by, now the thickness of the section is 250 mm. Okay, so let us do the calculations over here. So this is 0.24 divided by 100 multiplied by 1000 multiplied by 250. How much is this? कितना आ रहा है? AST कितना आ रहा है? 600 mm square. Please cross check someone. Exact 600 आ रहा है. Very good. अच्छा, ये मिनिमम है ना? ओके, ठीक है. So for 600 millimeter square, if you take 10 mm dia bars, okay, so 10 dia, how much will be the spacing? Sorry, 130. So 130, it is very close to 125. So we can have at 125 center to center. So both, that is this reinforcement as well as this reinforcement. Okay, so both can be 10 dia at 125 center to center. Okay, so this is how the bare minimum reinforcement has to be provided. Okay, there is a clause of minimum reinforcement for the design of base slab. What it says, I have already underlined it with the red color. So it says for a ground slab, okay, which is less than 300 mm thick, which is in our case it is 250 mm thick, the calculated reinforcement should be placed on the one face as near as possible to the upper surface consistent with the nominal cover. Okay, I hope the statement is very clear to everybody. Okay, the bar spacing should generally not exceed 300 mm or the thickness of the section, whichever is less. Okay, so our spacing is also 125, so it is not greater than 300. Okay, it is less than 300, and the thickness of the section is 250, so definitely it is less than that one also. So as per this clause, whatever reinforcement we have designed, it is perfectly fine. Okay, so now the same reinforcement can be continued, and then we can go for the some checks which we have to perform. For this purpose, we need to find out what will be the outer diameter or the area of the base slab. Okay, so here let me draw one more figure for you. So this is your wall. Okay, so this diameter is basically 6.6, I suppose. बराबर है? था 6.6 ही था ना? Clear diameter? Yes, 6.6. Okay, so this was 6.6, and the thickness. So thickness of the wall was 150 I suppose, ठीक है. और उसके बाद हमने प्रोजेक्शन दिया था कितना 75 का, बराबर है. सो हियर देयर विल बी अ स्ट्रक्चर विच इज समथिंग लाइक दिस, right? So this is 6.6 from here to here, this is 6.6, okay, plus 150 plus 150, so that becomes 6.9 meters, okay. So 6.9 plus 75 this side, 75 that side, so that comes out to be 1.5, 150. So 6.9 plus 150, that comes out to be 7.05. So this diameter, this is 7.05. So this is d outer diameter, okay. So this is 7.05 meters. So the base area, so here I'm talking about this area over which the UDL will be acting in form of a support reaction. So that how much will be this area now? Can someone tell me this value please? Pi by 4 d square, d outer square, how much is this? Sorry, 39.03. Someone please cross check.
Yes, sir.
39.03 meter square, okay. This will be required in further calculations, okay. So let us do this calculation. First, stability check we have to check. So for stability check, the first is the self-weight of the tank, okay. So we have to calculate what will be the self-weight of the tank. So self-weight of the tank consists of the weight of the dome, weight of the ring beam, weight of the wall, weight of the slab, okay. There are four components, four major components, okay. I'm not talking about the weight of the water. So if you take the weight of the dome can be calculated by expression 2 pi capital R, then small r, which is rise, thickness of the dome plus the density of the concrete, okay. So this is the standard equation to calculate the weight of the dome. So this capital R, if I remember, it is something like 8 point something, yeah, 8.58, okay. So this is 8.58. A small r is 0.66 I suppose. The thickness of the dome was 0.1 and density is 25. How much is this? Please bring calculators, everybody. 20, 88.95. Okay. So this is 88.95 kilonewtons. Okay. Then we have the ring beam. Okay. So we have to calculate the ring beam area. So we have assumed this as 0.2 meters. Depth is also 0.2 meters. The pi value is already known. Then we have to calculate the d average. Okay. So now let me draw a figure for you. So this is your beam, okay. We have a dome which is like this, and then we have a wall like this, okay. So here diameter is I think 6.6. diameter कितना अपना 6 point ना, exact diameter value बताओ यार. 6.6 meters, okay. So this is 6.6 meters, and if you consider the diameter at this level, okay, at this level, so this will be 6.6 plus 0.2 and plus 0.2, that comes out to be 7, okay. So here the diameter, if you take at the center over here, so this will be how much? 6.8, okay. So at this level your diameter here, this will be 6.8 dia. So this is the average diameter, so this is 6.8. The density of the concrete is again 25. So how much is this now? $21.36 kilonewton, okay. Then we have to find out the weight of the wall. Okay, so the thickness of the wall, I think we have assumed this as 0.15. Okay, the height of the wall, okay, remember the depth of the water was 3 meter, isn't it? And height of the wall we have taken this as 3 point, कितना था 3.3 including the freeboard, isn't it? Please check. ठीक है, so here we have to take the height of the wall, so this is 3.3. okay, then pi, and again we have to calculate the d average, because here you see this is the wall, I'm talking about wall over here. The diameter which is over here is 6.6, the diameter which is over here will be 6.6 plus the thickness of the wall plus the thickness of the wall. So the thickness of the wall is 150 mm. So twice the thickness of the wall is 0.3. So 0.3 plus 6.6 is 6.9. Okay. So this is 6.9. So here the diameter ये कितना आएगा 6.75 बराबर है 6.75 बराबर है ना 6.75 ठीक है. So here we have to take the value as 6.75 and this is 25. How much is this self weight of the wall? This will be very large value. कितना 874. Like I said earlier, ये थोड़ी सी ज्यादा वैल्यू रहेगी. कितना है 874. बस इसके आगे कुछ है 874 पॉइंट, तो 875 कर दे 875 किलो न्यूटन. ठीक है, सो दिस इज द weight of the wall. Then we have to calculate the weight of the base slab. Okay, so weight of the base slab, you can calculate area into thickness of the slab into the density of the concrete. So we have already calculated the outer diameter. Okay, so outer diameter is 7.05, isn't it? So here all we have to do is this value is 7.05, thickness is 0.25, density is 25. How much is this? किसका कौन सा वाला कितना आ रहा है 262. आर यू श्योर? हाँ, तो मैंने 0.15 लिखा है, नॉट 0.5. चेंज करना है इसको. दिस इज एक्चुअली ये लिखते समय गड़बड़ आई. दिस इज 15 ओनली. So this is, how much is that? Sorry, 262.5. ठीक है, ठीक है. हाँ, weight of the slab, please do the calculations. टू 44 कर दे, चेक करो. Is it so, girls?
Yes, sir.
बोलो भाई, करेक्ट है? ठीक है. So now we have the weight of dome, weight of ring beam, weight of wall and weight of slab. So just sum them up and give me the total weight of the tank. कितना आ रहा है? That is 88.95 plus 21.36, then 262.5 plus 244. सिक्स 616 हाँ तो 617 कर दें, ठीक है गर्ल्स बराबर है. So this value, so the total, this is 617 kilonewton. ठीक है. So this is the total weight of the tank, right? So we have already calculated the total weight of the tank. Now let us calculate how much is the weight of the water which will be there inside the tank. Okay. Remember, we have considered the height of the water as 3.3. Although it is designed for 3 meter depth, but while for calculations, the we are considering the worst case scenario where the freeboard is also filled with water. Okay, so for this purpose we have to do this calculation. So the diameter of the inner diameter of the tank, I think it is 6.6 meters. Okay, the height of the water now it will be 3.3 meters, and density of water is 10. So how much is the weight of the water in the tank? One one 1129. It is designed for 1000 और rather 100 मीटर क्यूब, है ना. 100 मीटर क्यूब के लिए हमने डिजाइन किया था, बट सिंस वी आर कंसिडरिंग द फ्री बोर्ड, दैट्स व्हाई इट्स वॉल्यूम इज स्लाइटली मोर, बिकॉज ऑफ दैट इट्स वेट इज ऑल्सो स्लाइटली मोर. Okay, so now our initial calculations which are required for the stability check is now over. So we have calculated the weight of the tank, we have also calculated the weight of the water. So you can see the weight of the tank is nearly half of the weight of the water. Okay, so now let us see what is going to happen. Now first we are going for the tank empty condition. Okay, so whenever there is a tank empty, the downward force will be only the weight of the tank, isn't it? So the weight of the tank we have already calculated as 617 kilonewton. So the downward force in kilonewton will be something like 617 kilonewton. बराबर है. So we have to calculate the upward pressure intensity. So for calculating upward pressure intensity, whatever load is there divided by the base area. So we have already calculated the base area of the tank as 39.03 meter square. Okay, this we have already calculated. So this is 39.03 meter square, whereas the pressure is 617 kilonewton. How much is this? 617 by 39.03. बहुत कम आएगा, because it is only for the self weight. Sorry, 15 point. This is kilonewton per meter square. This is less than 100, because in the problem itself it is given the SBC of the soil should be taken as 100 kilonewtons per meter square. Okay, so as far as tank empty is there, we are safe. Your SBC is much higher and upward pressure intensity is much lower. Now let us talk about when the tank is full. Okay, so when the tank is full, the weight of the tank will come into picture, as well as the weight of the water will also come into picture. So the weight of the tank is 617. So this is 617, and the weight of the water you have calculated as 1129. Okay, so this is 1129, and the base area is 39.03. So this is 39.03. So this P is nothing but 617 plus 1129. Now tell me how much will be the upward pressure intensity below the tank? Sorry, 44. ठीक है, so this is coming out to be something like 44 kilonewton per meter square. This is definitely less than 100, so we are safe. ठीक है, so as far as stability check is concerned, whether tank is full or tank is empty, you are safe. The structure is not going anywhere, it will be safe. Okay, but when there is a rainy season, what will happen? So you can see in this particular picture, water level is mentioned. So usually water level is well below the foundation in other seasons, but especially in rainy season, what happens, the water level may rise. Okay, so whenever there is a rise in water level, there will be a upward pressure which is coming from the bottom due to rise in the water level. Whenever the water level is high, the risk of upliftment of the tank is also high, because जितना तुम्हारा पानी ऊपर चढ़ेगा उतना तुम्हारा प्रेशर ज़्यादा आएगा. Okay, so now we have to take care whether the tank is safe in uplifting or not. So for this purpose, we are assuming the extreme scenario. So the extreme scenario is what? When the water level is, the groundwater level is very much same as your ground level itself, which is there in the second figure. तो तुम्हारा पानी जो है वो पूरा ग्राउंड लेवल तक पूरा पानी जो है सैचुरेटेड है. ओके, योर सॉइल इज कंप्लीटली सैचुरेटेड. So now in this case, what will happen? The water is going to create an extra pressure from the bottom. So let us see how it is going to happen. So for this purpose, let us first of all calculate the upward force, or sorry, the downward force. So downward force consists of the weight of the tank plus the weight of the water. Okay, so the weight of the tank we have already calculated. This has 617 and the weight of the water is 1129. तो ये टोटल कितना आ रहा है? कितना? 1746 kilonewton. Okay, so this is the total load which is coming downward. Okay, now if this is the case where the water level is reaching up to the ground level, you will be subjected to a upward pressure. Okay, so upward pressure can be calculated by simple expression, water depth into the density of the water straight away. Okay, so here you see, here we have a clear distance of 3 meters. Okay, plus we have a slab over here which is 0.25 meters. Okay, so water level, so here this much pressure or this much height is nothing but 3.25. so basically this will be 10, this will be 3, the thickness of the slab is 0.25. So how much is this upward pressure, upward force? Sorry, 10 into 3.25, that comes out to be 30.25. 32.5, sorry, 32.5. This is kilonewton per meter square. Okay, this is the per meter square area. So this will be multiplied with the cross section area of the slab. So slab का cross section area कितना है? We have already calculated this. It is 39.03. Okay, so if you multiply this with 39.03, you will be getting the upward force. ठीक है, तो how much is this multiplication? 32.5 multiplied by 39.03. कितना है? कितना आ रहा है? 32.5 multiplied by 39.03. Sorry, 1268. ठीक है, so now you see the upward pressure, oh sorry, downward pressure. This downward pressure is 1746, whereas your upward pressure is 1268. So this is safe, है ना, because the effective pressure is going towards the ground, right? So whenever there is a tank full, so whenever there is a rainy season and the groundwater level is same as your ground level, but your tank is full. In that case, your structure is safe. Okay. Now let us see when tank is empty. Okay. So when tank is empty, the only downward force which is acting is 617. That is the self weight of the tank. बराबर है? And your upward force, just now we have calculated the upward force, it is 1268. Okay, so this is nothing but 1268. So basically the downward force is 617, but the upward force is 1268. This is not going to solve, this is not going to happen, right? So in this particular case, your water, groundwater, is going to create a pressure which is acting vertically downwards and which is not getting compensated by the self weight of the structure. So because of this, what is going to happen? So your tank will be uplifted. Okay. So now how to prevent this? How to prevent the upliftment of the tank, especially in the rainy season and whenever there is a water level which is up to this. So one way or the only way of doing this is you increase the downward force. Okay, so right now the only downward force is 617, which is the self weight of the tank. So one way of doing this is you increase the self weight of the tank. And how to increase the self weight of the tank? You can increase the thickness of the slab, ठीक है, थोड़ी सी मोटी slab डालो, ठीक है, और you can increase the thickness of the wall also, because you see slab and the wall, they contributes more towards the self weight of the tank. Okay, if you see these values over here, when we have calculated, so weight of the dome is hardly 88, ring beam is hardly 21, but if you see the weight of the wall, it is 262, and the weight of the slab is 244. Okay, so one way of doing this is you increase the dimensions, and you have to increase the dimensions such that your downward force should be at least 1268. Okay, one way of doing this is, but this is a very uneconomical solution because we have to increase the self weight, so you need additional concrete, additional steel, and everything is going to cost you a lot. Okay, second way of doing this is you can ask the owner to maintain a water level up to certain height, so that जो भी तुम्हारा बैलेंस वाला लोड है, that can be taken care by the water. So you have to instruct the owner that whenever there is a rainy season, you have to keep water level up to this height only. Okay, so that for this much of height, it will be taken care. I mean, the downward force will be acting. Additional water level is going to create the downward force. So for this purpose, what you can do is you can have a downward force same as the upward force. Okay, so the downward upward force we have already calculated. Upward force is 1268. Okay, so let me write down over here. This is 1268. Okay, the weight of the tank is 617. This is 617. So we have to find out how much water weight should be there in the tank so that it will be balanced. Okay, तो ये कितना आएगा, वाटर का वेट कितना आ रहा है, or rather water weight can be calculated as pi by 4 into d square into hw into gamma, where d can be 6 meters, नहीं 6 point कितना है अपना, 6.6 I suppose. Okay, height of the water is unknown, this is 10. So can you tell me how much is this height? So weight of the tank plus weight of the water should be same as the upward force. Okay, so we are calculating how much height is required to maintain the equilibrium. 1.8. Someone please check. Is it 1.8? Yes, please someone cross check. Is it 1.8? 1.8, 1.9, एग्जैक्ट वैल्यू कितनी आ रही है? 1.902, 1.91. ठीक है, तो in place of going for 1.9 I am going for 2 because we need to ensure the safety, isn't it? So this height should be maintained as 2 meter. So what is going to happen over here is, so now here we have a depth of the water as 2 meter. So definitely this is going to create a downward force. Okay, plus there is a this weight, okay, that is the sulfate of the structure. This is also going to create a downward pressure. So this combined pressure, that is the weight of water plus sulfate, this is going to be compensated with 1268. So they will be balancing each other. So this is a most economical way of preventing the upliftment of the tank, especially in the rainy season. Okay, so this is one way. So we have discussed the prevention, that is increase the thickness of the wall, thickness of the slab, and maintaining the water pressure. Right. There is another way of doing this, that is increasing the projection of the base slab. Okay, so if you want, you can go for the increased projection of the base slab. So let me draw a figure for you. So what you can have, you can have a large projection which is like this. Okay, so if you have a large projection, over here there will be a soil. Okay, so even if the tank is empty, so your downward pressure will be the sulfate of the tank plus the pressure which is coming from the soil. But in this particular case, what is going to happen is your slab is going to bend like this. Okay, so for this purpose you have to design the slab. तुमको bending calculate करना पड़ेगा and then we have to design this. Okay, but again this is not uneconomical because unnecessarily you are increasing the projection, your steel is increasing, your thickness is also increasing. Okay, so the best and the safest and most economical way is to maintain a 2 meter depth water level, especially in the rainy season. Okay, so I expect that everybody has understood this design, that is design of top dome, ring beam, wall, as well as foundation plus the checks. Okay, so this completes the GSR topic. So probably end of the day or probably tomorrow I'll give you one assignment on this where you have to design the complete water tank. Okay, are there any queries? Yes, online students, are there any queries?
No, sir.
No, sir.
Okay, well let me uh, stop recording and let me quickly take your attendance. Okay.